This is Dr. M.Komala, Professor, Department of Pharmaceutics, School of Pharmaceutical Sciences, Vistas, Pallavaram, Chennai. I am going to discuss about the disinfectant and antiseptic. First, we'll see the different content in this antiseptic and disinfectant. First, I'll start with the terminologies used in the disinfectant and antiseptic. Then introduction of disinfectant, classification of disinfectants, mode of action of disinfectants, factors affecting disinfection, evaluation of antimicrobial agents and disinfectants. Then what are the different terminology used in the disinfectant and antiseptic? First is sepsis, it's a bacterial contaminations. Asepsis is absence of significant contamination. Antisepsis is chemical destruction of vegetative pathogens on living tissues. The next bactericidal is a chemical agents capable of killing bacteria. Virucidal chemical agents capable of killing virus. Fungicidal chemical agents capable of killing fungi. Sporocidal chemical agents capable of killing spores. And bacteriostatic is a chemical agents that inhibit the growth of bacteria. The next is the what is meant by disinfection. Disinfection is the process of destruction or removal of microorganisms and reducing them to the level not harmful to health. This disinfection generally kills the sensitive vegetative cells but not heat resistant endospores. If the object is inanimate, like working area, dishes, benches, etc., then the chemical is known as disinfectant. If the object is animate, like human body, tissues, the chemical is known as antiseptic. The next we'll move on to the ideal disinfectant. The disinfectant should be broad spectrum and should be non-toxic. It should be fast acting, odorless, surface compatibility, economical, and should be easy to use. It should be soluble and miscible and not affected by the physical factors. And finally, it should be stable on storage. The next is the classification of disinfectant, acids and alkalis, aldehyde, halogens, quaternary ammonium compounds, heavy metals, dyes, phenol and its derivatives, alcohols, detergents, and soaps. Then details of acids and alkalis. It generally strong acids and alkali kill the bacteria, but weak organic acids inhibit their growth. Then halogens like chlorine, fluorine, bromine, and iodine in free state as well as their compounds strongly act as germicidal. Heavy metals like mercury, silver, and copper. Heavy metals and their compounds act as antimicrobially by combining with the cellular proteins. High concentration of salts of heavy metals like mercury, copper, and silver coagulate cytoplasmic proteins, resulting in the damage or death of cell. The next is phenol and its derivatives. Phenol is the cheap products obtained by the distillation of coal tar. Phenol 1% has bactericidal action. Then next is your alcohol. Alcohols have fairly rapid bactericidal action against vegetative bacteria when diluted to the concentration of 60% to 70% volume by volume with water. Ethanol 60 to 70% volume by volume and isopropanol 50 to 60% volume by volume are used as skin disinfectants, while methanol vapor has been used as fungicide. The higher alcohols, propyl, butyl, amyl, are more germicidal than ethyl alcohol. Alcohols are used as a preservative in some vaccines. And next is the aldehyde. Like formaldehyde is the main aldehyde used for disinfection process. Formaldehyde in solution is useful for sterilization of certain instruments. The next is quaternary ammonium compounds. The quaternary ammonium compounds are widely used for control of microorganisms on floors, walls, nursing homes, and other public places. They are also used as a skin antiseptics and as sanitizing agents in dairy, egg, and fishing industries. And dyes, a number of dyes have been used to inhibit the bacterial growth. Basic dyes are more effective bactericides than acetic dyes. Acridine and triphenyl methane dyes are commonly used as antimicrobial agents. Next is the detergents and soaps. So these are widely used as surface active agents, wetting agents, and they are classified into anionic, cationic, non-ionic, and amphoteric. The most important antibacterial agents are the cationic surface active agents, examples citramide, benzalkonium chloride, etc. Soaps and sodium lauryl sulfates or anionic compounds. Soaps prepared from saturated fatty acids are more effective against gram-negative bacilli, while those prepared from unsaturated acids have greater action against gram-positive. Non-ionic detergents are not ionized, however, these substances do not possess significant antimicrobial activity. Amphoteric compounds have the detergent properties of anionic surfactants combined with the disinfectant properties of cationic surfactants, example Tego compounds. The next is the mode of action of disinfectants. The first is the alteration of membrane permeability and its damage to proteins. And next mode of action will be rupture of cell membrane, then damage to nucleic acids, finally interfere with metabolic pathways. The next is the factors affecting disinfection process. First is the concentration of disinfectant, next is temperature, time of contact, pH of the environment, surface tension, formulation of disinfectant, chemical structure of disinfectant, types and number of microorganism presence, interfering substance in the environment, potentiation, synergism, and antagonism of disinfectant. First is the concentration of disinfectant. The lethal effect of bacterial population is increased by increasing the concentration of disinfectant. However, the effectiveness is generally related to the concentration exponentially, not linearly. That is the optimum concentration of phenol about 1%. Beyond this concentration, the disinfecting effectiveness becomes less. The dilution coefficient can be calculated by n is equal to log T2 minus log T1 divided by log C2 minus log C1. Here, n is the concentration exponent or dilution coefficient for disinfectant. T1 is the death time with the disinfectant concentration. T2 is the death time with the disinfectant concentration C2. The next factor is temperature. The lethal effect on bacterial population can be increased by increasing the temperature. The next, time of contact. A sufficient time of contact must be allowed for the disinfection to exert its action. The next is pH of the environment. Phenolic and acidic antimicrobial agents usually have greater activity in acidic conditions. Acridine dyes and quaternary ammonium compounds are usually more active in alkaline than in acidic solutions. Amphoteric antimicrobial, for example, Teco compounds, have optimum activities at widely differing pH values. The next is chemical structure of disinfectant. Chemical structure of compounds affect the disinfectant activity. Substitution of an alkyl chain up to 6 carbons in length in para position to phenolic hydroxyl group increases activity, but greater than 6 carbons in length decreases water solubility and disinfectant activity. Generally, halogenation increases the antibacterial activity of phenol, but nitration increases antibacterial activity and systematic toxicity also. The next factor is types and number of microorganisms present. The efficiency of disinfection greatly depends on the nature and the number of contaminating microorganisms and especially on the presence and absence of bacterial spores. The next factor is interfering substances in the environment. Materials like blood, body fluids, pus, milk, food residues, or colloidal proteins may reduce the effectiveness of disinfectant if present in small amounts. The presence of oil and fat markedly reduce the disinfection ability of phenolics. Then finally, potentiation, synergism, and antagonism of disinfectant. Potentiation of a disinfectant leads to enhanced antimicrobial activity. Synergistic effects are often shown by the two antimicrobial agents, which is giving an increased activity. Antagonism effects are often shown by two antimicrobial agents, which is giving an decreased activity. Then finally, the evaluation of antimicrobial agents and disinfectant. So this can be done by tube dilution and agar plate method, cup plate method or cylinder plate method, ditch plate method, gradient plate method, and phenol coefficient method. This is nothing but the RW test. First is a tube dilution and agar plate method. The chemical agent is incorporated into nutrient broth or agar medium and inoculated with test microorganisms. These tubes are incubated at 30 degrees Celsius to 35 degrees Celsius for 2 to 3 days, and then the results in the form of turbidity or colonies are observed. The results are recorded and the activity of the given disinfectant is compared. So this is the image of tube dilution and agar plate method. The next is cup plate or cylinder plate method. The nutrient agar is melted, cooled suitably, poured into petri dish, spread 0.2 ml of known concentration of inoculum on the surface of the solidified agar. Then cups or cabbages are made by using a sterile borer. Then 0.2 ml of drug is poured into the cups of agar plate and then incubated at 37 degrees Celsius for 24 hours. If the drug has any antibacterial effect, it will show the zone of inhibition. This is the image of cup plate or cylinder plate method. The next is the ditch plate method. The nutrient agar is melted, cooled suitably, poured into petri dish. The solidified media is cut with a sterile blade to make a ditch. The drug is poured very carefully into the ditch. Various microorganisms are streaked on the sides of the ditch. This method is used to find out the potency of drug against various microorganisms by the means of inhibition of growth on streaked area. This is image of the ditch plate method. Then gradient plate technique. This technique is used to isolate the resistant mutants. The petri dish is kept in slanting position and a sufficient amount of melted nutrient agar is poured and solidified in slanting position. Another layer of agar is poured over it, which contains antibiotic solution and solidified it. After solidification, 0.2 ml of bacterial culture was spreaded over the solid surface and incubated at 37 degrees Celsius for 24 to 48 hours. The microorganism will grow where the concentration of the drug is below the critical level. The antibiotics get diluted on the lower layer and the gradient of concentration will be produced. Thus, the resistant mutant can be isolated. This is the image of the gradient plate technique. Finally, phenol coefficient method. This is otherwise called radial Walker test. Phenol coefficient test is suitable for testing the disinfectant miscible with water and which exerts their antimicrobial actions. So the test organism used for this evaluation test is Salmonella typhi, and the standard disinfection used is the phenol. So different dilution with test disinfection and phenol are prepared, and 5 ml of each dilution is inoculated with 0.5 ml broth culture of the organism for 24 hours. All tubes as disinfectant plus organism and with phenol and organisms alone are placed in 17.5 degrees Celsius water bath. Subculture of each reaction mixtures are taken and transferred to 5 ml sterile broth after 2.5, 5, 7.5 and 10 minutes. The broth tubes are incubated at 37 degrees Celsius for 48 to 72 hours and are examined for the presence or absence of growth. This is a table which shows the different dilution as well as that is how that bacterial growth based on the time interval after subculture. So both test disinfectant as well as phenol will be given over here. So RW phenol coefficient is equal to dilution of disinfectant killing in 7.5 but not in 5 minutes divided by dilution of phenol killing in 7.5 but not in 5 minutes. If a phenol coefficient or RW coefficient of a given tested disinfectant is 1, it means that disinfectant has same effectiveness as phenol. If a phenol coefficient or RW coefficient of a given test disinfectant is less than 1, it means that the disinfectant is less effective than phenol. If a phenol coefficient or RW coefficient of a given test disinfectant is more than 1, it means the disinfectant is more effective than phenol. If the phenol coefficient of the test disinfection is 20, It means that the disinfectant is 20 times more active than phenol. So that's all about disinfectant and antiseptic. Thank you.